Hello. Hi, Hasni. How are you? I'm good. I'm good. Thank you for asking. How was your day at school today? Mm, amazing. That's so good to know. Brilliant. All right. So just from our last lesson, we started looking at different types of chemical reactions, and I had given you some homework in last lesson. How did that go? That's good. That's good to know. So which type of reaction did we look at in last lesson? Combination reaction. That's good. Yes, that's right. And what is combination reaction, Hasni? Yes, it is a reaction. Mhm. Two or more elements and or compounds combine together. That's right. And they produce a single product. Very good. Very good. I just have a question about a combination reaction. So, what is it? Say, for example, if we talk about the combination of two gases, hydrogen and oxygen, and the resultant substance is water. So, what type of change it is? Is it physical, chemical? And why do you think it is what it is? It is a chemical reaction. That's right. That's right. It is a chemical reaction. And why do you think it's a chemical reaction? Yes, because the chemical properties of hydrogen as well as oxygen gas change, and a completely new product with entirely different chemical properties is produced. Very good. So let's write the title for today, types of chemical reactions. And we've already had a look, we've already discussed all about combination reaction. We've discussed different types of combination reaction. By different types, we mean two elements forming a product, or one element and a compound forming a product, or two different compounds reacting to form a product. Very good. And I appreciate that you still remember. Good. And let's look at another type of reaction, which is decomposition. Now, you must have already had the curriculum with you. And in last lesson, we agreed upon sticking with the sequence of the types of reactions according to the curriculum. Do you still agree? Or you want to look at a different type of chemical reaction? So you want to stick to the plan? Okay, all right. So, as per the curriculum, as per the plan, the second type of reaction that we are to look at is a decomposition reaction. So, in your notebook, quickly give the heading decomposition reaction and let's talk about it. What is decomposition? What do you think it is? Like whatever comes in your head first. Like close your eyes, say decomposition, and see what you see. What do you see? You see a plant. What else? You see plants breaking down. Okay. Yep. How will a plant break down? By microorganisms. Uh-huh. That's right. So what you are talking about, that's plants breaking down or plants decomposing by microorganisms in soil. Yeah, that's a natural way of decomposing organic matter, which is true. Yes, it is true. In chemistry, being chemists, we have that magical wand in our hands. So in your school laboratory, even you can perform this chemical reaction. It's a simple chemical reaction. Now, also, it is a reverse of what we learned about combination reactions. Combination reactions is when two or more substances absolutely fit in together and produce one single product. A decomposition reaction is exactly reverse of a combination reaction. With that, I mean we have only one chemical reactant, and then that splits up into two or more different products. So say for instance, we have something which is AB, then that decomposes into A and B. Do you have any questions so far? No? It's all going good? Yes? Wonderful. Um, let's talk about some real life examples. The one that you said, that is decomposition of organic matter. Yes, that's a chemical reaction that happens in nature, but do you see it happening very quickly or it takes time? Yes, yes, that takes time. That takes time. Can you think of something where you get two or more things from a single thing and it happens quickly? Mm, think about it. So you are thinking about that one single let's call it as a substance, that one single substance, and then it's giving you two or more different substances. Sharpening a pencil, giving you pencil sharps. No, no. Yeah, think about breaking, think about splitting. Splitting, a decomposition reaction. Yeah, yeah, like for combination reaction, we discussed different real life examples of combination reaction that happens in day-to-day life. Addition of two things together to make one thing, right? Like we discussed cooking. So, or baking, we add a lot of ingredients together and then we come up with one dish, isn't it? And every single ingredient loses its properties, and then you have a final product which tastes different. Yes, so that's a real life example for combination reaction. Can you think of something which is a real life example but a decomposition reaction? Uh-huh. Photosynthesis. Photosynthesis is again a combination reaction, isn't it? Because you have carbon dioxide, you have water, and presence of that, plants prepare their own food. So to prepare. Let me give you a chemical reaction, and then we will discuss where this reaction happens in day-to-day life. Let's talk about breaking or decomposing liquid water to the reactants that it is formed from. So that's hydrogen gas and oxygen gas. Now see how one chemical substance is breaking down or simplifying into hydrogen and oxygen. So from it's going down to, it's breaking down to its elements from what it is formed, right? Yeah, oh, thank you for reminding. The reaction is not balanced. That is so good. You're a very good observer, Hasni. Mm. And then, do you remember how to balance a reaction? The number of atoms on each side of the arrow should be equal. Very good. We have two hydrogens on the left, we have two hydrogens on the right, which is balanced. We have one oxygen on the left and we have two oxygens on the right, which is not so balanced. So we got two atoms of oxygen on the right-hand side. And we need to write a big 2. Remember the coefficient, and we cannot change the formula. We cannot write a 2 there. That's so good. And then now what has happened is there are 4 hydrogen atoms. What do I do? Add a 2. Yes, add a 2. And now I have a balanced reaction. Do you see ever if you leave a glass of water overnight and it disappears because it has given you oxygen and hydrogen gases? Nah, no. Yep, that doesn't happen, which means you need something. You need a condition. What it could be? Strong heating, very good. It's very strong heat, yeah. Yes. Electricity, yes. Or electric current, yes. Very well possible. Electric current, wonderful. Now, depending upon what we are providing to the reactant, the decomposition reaction has got different names. Yes, chemists like to have different names. Yes, we just love classifying stuff. So if you are heating a substance and then that substance decomposes, that decomposition is called thermal. So therm should remind you of heat. Thermal decomposition. And if you provide electricity, electric current, and you try and split the substance, and that is electrolysis. So if you use electricity, that is called electrolysis. Electro is electric current. Lysis is a word, I guess Latin word, that means breaking. So breaking a substance by providing electricity. The two different things. In our lesson today, we are going to just focus on thermal decomposition reactions. Are you all good so far? So what you can do is you can take the screenshot just to save upon time, or if you want to handwrite things down alongside the session, you can even do that. Please let me know if you are handwriting and you need some time, you want me to stop. Please let me know, I will stop. Okay? Yes. Yep, good so far. So no questions. Do you understand, Hasni, why substances do not change on their own? Yeah. They need something. They need heat or they need electricity. Yeah, very good. Some chemicals need pressure. Yes. You remember now? Yes, tell me. Yes. Firecrackers? Awesome. Yeah. There are some. No, you're right. You are right. So, exactly, combustion reaction. Combustion reaction is when you burn firecrackers. They are these tiny packets. They are also a type of firecrackers. And as soon as you throw them on the ground or you hit it hard with an object, yeah, they burst. That's right. So they need pressure. Exactly. Yeah, so electricity or heat or sometimes even pressure can start a reaction. A reactant can break down a reactant. That's right. That's correct. Wonderful. So, as I said, for today's lesson, we will just focus on decomposition reactions, which are initiated by passing heat. Yep. Yes. Okay. So let's just quickly talk about, I have solid sodium chloride, right? And I hate it. And what I see is it is molten now. Yeah, it will melt. I have one reactant, I've provided heat, and what I see is it's still the same chemically. Would you classify this as a decomposition reaction, a thermal decomposition reaction? No. Yeah, no. And why? Yeah, exactly. So the point is sodium chloride before the reaction is sodium chloride, solid, and after the heat, after you've provided heat, it still remains sodium chloride chemically, although it has changed its state of matter. So it is a physical change, it is not a chemical change, hence it is not thermal decomposition reaction. Very good. Very good. I'm really proud of you. Yeah. Now let's look at this substance. It is a solid, and I'm gonna heat it, and it produces copper oxide and carbon dioxide. Now what is this? Physical change, chemical change? Chemical change? How can you say it so confidently? Because they are different, yes. Because the products are different, yes. Yep, copper oxide is solid, carbon dioxide is gas. The color change, very good. The colors changed, yes. Right. Now what I'm gonna do is I will um nope, not that. Mm, hang on. I was just trying to pull out the screen share option. Did I find one? Okay, never mind. What I'll do is at the end of the lesson, I'm gonna share two links with you. So one link's gonna be the video link to give you visuals of this particular chemical reaction that we are talking about. And the second thing is I'm gonna send you a link which will take you to Quizlet. And I've set some questions for thermal decomposition reactions. So, and then you can do this in your own time, like before we meet the next lesson. And if you have any questions, feel free to ask. Yeah, homework. Yeah, yeah, that's going to be your homework. Yes. Yeah, so the Quizlet questions going to be your homework questions. You do them, and if you have any difficulty doing any of these, you please ask me in next lesson. Yeah, yes. All right. So, is this reaction balanced, Hasni? Yes. The three atoms of oxygen, one atom of oxygen plus two atoms of oxygen, one copper, one carbon, one carbon. Yes. Right. Thermal decomposition reaction. Perfect. Now from this, just from this, do you remember how to write confirmatory test for carbon dioxide? Like, how do you know if the reactions has reached completion? How do you know if the gas is carbon dioxide? That's okay. That's perfectly fine. I will help you. Uh, yeah, not a problem. Not a problem. So carbon dioxide gas, the confirmatory test for carbon dioxide gas is um, when carbon dioxide, we'll extend that. Yep. When carbon dioxide gas is passed through clear lime water, the clock is ticking, but I will be really quick, I promise. Clear water, it turns milky, up milky, and upon excess CO2 addition, lime water becomes clear again. Yes. Yep, that's right. That's fine. And we've had a look at the YouTube video as well, like how it happens. Yes, and we've discussed the reasons. Yes, thumbs up. Okay, not a problem. Not a problem. Thank you very much for joining the session. Thank you so much for joining the session. Remember to complete homework. Yeah, yes. So, how was it? Did you enjoy the session? Did you understand the session? Right. What type of reaction we looked at? Decomposition. Yeah. Did we look at electrolysis? Nah, not yet. Right. Right. So we've just had a look at what is decomposition reaction and in particular thermal decomposition reaction of copper carbonate. So two things for you to do today or whenever you get time just before we meet next. Number one is to be able to watch the video, your copper carbonate going down to copper oxide and carbon dioxide. So you watch that. It will help you remember stuff and will give you that visual, right? Support. And the second thing that you'll do is you'll do the homework, the Quizlet questions. Right. I'll see you in the next lesson, Hasni. And happy learning. Bye-bye.